Welcome to Distance Learning with Lee, where I make learning mathematics super easy. On today's video tutorial, we will be going through question 3 of the Mathematics Paper 1 November 2020 grade 12 exam. This question covers the topics on sigma notation and infinite geometric series. So please make sure that you are subscribed to the channel. Please comment on the video tutorials and share the tutorials with your friends. And before we get started, please make sure that you copy down the questions and attempt them on your own. And once you've done that, play the video and follow to see if you understood everything correctly. I will be doing a separate video tutorial on sigma notation and infinite geometric series. So please make sure that you are subscribed and you hit the notification bell to get notified every time I upload a new video tutorial. Okay guys, so let's get started. Okay, so like I mentioned, we're going to be doing the question 3 of the November mathematics November 2020 paper 1, and it is obviously covering sigma notation and your infinite geometric series. So guys, this is a great way to just revise and see that you understand everything. Okay, so if you've gone through your unit 3 of the Mind the Gap mathematics study guide, this is also a great way of just making sure that you understand everything. If you haven't studied or you're still going through your work, guys, the final exam is on the 5th of November. So you need to, you need to be quick, okay? But in any case, it's fine, guys. Let's get started with the video tutorial. Okay, so question 3.1 is asking us to prove that the sum of this geometric series, 4 times 3 to the power of 2 minus k, from k, which is equal to 1, to k, which is equal to infinity, is a convergent geometric series. And we need to show all our calculations. Okay, the first thing you need to ask yourself when you are answering this question is that how do you confirm that a series is a geometric series is convergent? Okay, how do you confirm that? Okay, and we know that a geometric series is convergent if you get a value of r that is in between -1 to +1, and your r is not equal to 0. Okay, I'm going to make that note there. Okay, so this is the question. I've just written it out. So a convergent geometric series, okay, I'm just making a note for you guys. A convergent geometric series has a value of r that is between -1 and 1, and your r cannot be equal to 0. So with this solution, we are basically trying to show that our r is between -1 and 1 and our r is not equal to 0. And if we can show that, then we can confirm that we have a convergent geometric series. Okay guys, okay, so let's get started in solving this problem. Okay, so we are given the sum of your geometric series, 4 times 3 to the power of 2 minus 1, from k, which is equal to 1, to k, which is equal to infinity. The first thing we need to do is just find the terms of we need to first find a few terms of this geometric series. How do we do that? We just simply use this formula, right? We just use this formula to find the terms of the sequence, right? So how do we use this formula? I'm just going to show you guys with our first term, right? The formula is saying your sigma k is equal to 1 to infinity 4 times 3 to the power of 2 minus Okay, how do we use that, right? We're trying to find the first term, and we know that this series starts at k, which is equal to 1. So we're going to start by substituting your k, which is equal to 1, right? So it's 4 times 3 to the power 2 minus 1, right? Okay, let's just make this like that so that you guys are not confused. K to the power of 2 minus 1. We substituted that 1. We're going to find what our answer is. So what is 2 minus 1, guys? So it's going to be 4 times 3 to the power 2 minus 1 is minus 1. Find what our value is. You should get a 12. Let's find out what our second term of this series is, right? You take your 4 times your 3 to the power of 2 minus 2, okay? And then it's 4 times 3 to the power of 0. And anything to the power of 0 is 1. Therefore, you get 4. Let's find our third term of this series. You take your 4 times 3 to the power of 2 minus 3, okay? And then 4 times 3 to the power of 2 minus 3. 2 minus 3 is minus 1. And that gives us a 4 over 3. And then let's just find the last term. Your fourth term, your 4 times 3 to the power of 2 minus, where you see the k, you put the 4. And that is going to be equal to 4 times 3. 2 minus 4 is minus 2. Okay, and then that will give you a 4 over 9. Okay, so now we found the first term of this series. We found the second term, the third term, and the fourth term. And now all we need to do is find the value of r and confirm whether the r is in fact between -1 and 1. And if it is, then we can confirm that this is in fact a convergent geometric series. Okay, I'm just going to write down the values that we got. We found that our T1 is equal to 12, okay, plus your T2, which is equal to 4, plus your T3, which is equal to 4 over 3, plus your T4, which we got to be 4 over 9. And we know that this series goes on forever. And then that is our T2, that is our T3, and that is our T4. When we're working with a geometric series, how do we check, how do we get our common ratio, guys? We get our common ratio by taking our T2 and you're dividing it with our T1. Then you're taking your T3, dividing it with our T2, and you take your T4, dividing it with your T3, and those values should be they should give you a common ratio. Okay, we're going to just take your T2 and you divide it with your T1. What do you get if you take your 4 and you divide it with your 12? What is the value that you get, guys? You get a 1 over 3. Okay, and then you can just check with the other ones. I'm just doing this so that you guys see. If you take your T3 and you divide it with your T2, what is our term 3? Which is 4 over 3. And if you divide that with our term 2, which is 4, what do we get, guys? 4 over 3 divided by your 4. If you punch that into your calculator, you get a 1 over 3. Okay, therefore, we see that we've got a common ratio, right? and the common ratio is our r, which is equal to 1 over 3. Okay, and therefore your 1 over 3 is a value that is in between your -1 and your 1. Therefore, it is in fact a convergent geometric series. Okay, therefore it is a convergent geometric series. Okay guys, so just doing a quick recap, we're trying to prove that the series is in fact convergent, right? You're trying to prove that the series is in fact convergent, right? So what's the first thing you need to ask yourself? You need to ask yourself the question that how does a convergent, what are the rules, or what do we know about a convergent geometric series? And we know that with a convergent geometric series, right, our r needs to be between -1 and 1, and our r cannot be equal to 0, right? So that tells that we are trying to find the common ratio so that we can prove that our common ratio, or our value of our r, is in fact between -1 and 1, right? How did we find our common ratio? We first had to find several terms that were used, the several terms in our series, right? So we found what our term 1 was by substituting it into our equation, and we found that our term 1 is equal to 12. We found our term 2 was equal to 4, term 3 was equal to 4 over 3, and our term 4 was equal to 4 over 9. After finding those terms, what do we know? We know that we can now calculate the common ratio. How do we calculate your common ratio? By using the rule that we know of calculating the common ratio of a geometric series, which is taking your term 2 divided with your term 1, taking your term 3 divided with your term 2, taking your term 4, dividing it with your term 3, and that should give you a common ratio, or ratio that is equal in all these values, right? So our ratio, we found that our ratio is equal to 1 over 3. Therefore, this is a geometric series because 1 over 3 is, I'm going to just use that, your 1 over 3 is between -1 and 1. Okay. Okay, guys. So that's how we do it. We're going to move on to our second question. Okay. Our second question is if the sum of this series 4 times 3 to the power of 2 minus 1 from k, which is equal to p, to infinity is to infinity, right? If the sum is that, so if the sum of 4 times 3 to the power of 2 minus k from k, which is equal to p, to k, which is equal to infinity, is equal to 2 over 9, we need to determine the value of p. We're given the sum. We're given obviously a geometric series, right? And then we know that the sum of this geometric series is equal to 2 over 9, right? And we need to use that information that we're given to determine the value of p. Okay. So guys, for this question, right, the first thing we need to do, we're just trying to find the value of p, right? So the first thing that I would advise you guys to do is just get what the terms of this series are, and just write down these terms in terms of p. Okay, once we've done this, having these terms and having them written down in terms of obviously our p, we will be able to basically find our common ratio by taking our obviously our T2 over our T1, T3 over our T2, right? And that will help us find our R. And once we found our R, we can work backwards right, to just determine what our P is. But then, okay, we're just going to start off with the solution, and you guys will see what I mean. Okay, so this is question 3.2, right? And we are given the sum of a geometric series. So we're given a sum where it starts from k, which is equal to p to infinity of 4 times 3 to the power of 2 minus k. And we know that the sum of this series is equal to 2 over 9, right? And we just have to determine the value of p. So what is p? Okay, so the first thing that I want us to do is just get the terms of this series, right? So our term 1 is equal to, right, this series starts at p. So when we see k, we're going to substitute p for our term 1 because it starts at p and it goes all the way to infinity, right? So we're going to do that. We're going to take your 4 times 3, right, to the power of 2 minus p because it starts at p, right? What will our term, so our term 1 is our p. Our first term is our p, right? What would our term 2 be for this series, right? You're going to take your 4 times 3 to the power of 2 minus p plus 1, right? P plus 1, right? Because we're moving from that p. So our first term is p. Our second term is p plus 1. And our third term is p plus 2. And going on like that, right, guys? So our third term will be equal to 4 times 3 to the power of 2 minus, so where we see our p for our third term, we're going to say p plus 2. And I'm also going to just do a fourth term, which is going to be 4 times 3 to the power of 2 minus, it's going to be p plus 3. Okay, just do that there. That our fourth term is equal to p plus 3. All right, so we are going to simplify this further. Okay, we said that your T1 is equal to 4 times 3 to the power of 2 minus p. We can't really simplify. We can't really simplify this. I'll just leave it as, 4 times 3 to the power of 2 minus p. We'll just leave it like that. For our second term, let's just simplify that. It's going to be 3 to the power of 2. Then I'm just going to change the color here so you can see. All right, we're multiplying this negative in, right? And it's obviously going to change the values that are inside the bracket, right? So it's 4 times 3 to the power of 2 minus p minus 1. Okay, going on to term 3, we get 4 times 3 to the power of 2 minus p minus 2. And then you also have for your term 4, 4 times 3 to the power of 2 minus p minus 3. Okay. We think we can simplify this further for your term 2. That makes your term 2 equal to 4 times 3 to the power of your 2 minus 1 gives us a 1 minus p. Okay. Then with your term 3, you've got a 4. You've got a 3 times 3. And then your 2 minus 2 is equal to 0. Then you're just going to be left with minus p. And last one, you've got 4 times 3 to the power of 2 minus p minus 3. So it's 4 times 3 to the power of 2 minus 3 is equal to minus 1 minus p. All right, so we found our first term of the sequence. Okay, we found the first term of our sequence. Okay, we found the first term of our sequence. We found the second term of our sequence series. We found the third term of our series. Excuse me. And we found the fourth term of our series, right? So now the next step that we know is we find the common ratio. Okay, so let's do that. Okay, how do you find the common ratio? We know that to find the common ratio, we take your term 2 divided by your term 1, term 3 divided by your term 2, and term 4 divided by. That's how you find your common ratio. You should get a common ratio. Okay, so let's do that and see if we do get a common ratio. So to get your common ratio, you get your T2 and you divide it with your T1. So what is our T2? What is our T2? We found that our T2 is 4 times 3 to the power of 1 minus P. Okay, so we want to write that down. Your 4 times 3 to the power of 1 minus P all over. What was our term 1? Our term 1 was 4 times 3 to the power of 2 minus P. Okay. And then we're going to simplify this further. Okay. What do we see? What can we do with these 4s? We can see that we can just cancel them out. Okay, we can see that these cancel out. You can just cancel them out, right? And you are going to be left with, you're going to be left with 3 to the power of 1 minus P. 3, right, to the power of 1 minus P all over 3 to the power of 2 minus P, right? And then, guys, what do our exponential laws tell us, right? If you're dividing your exponents and you've got the same base, you can subtract the exponents, right? We've got the same bases and we're dividing, we can subtract the exponents, right? So let's do that. Okay, so that means that we've got, that can be written as 3 to the power of 1 minus P minus, we are subtracting the exponents that are in the denominator, right? You want to put a bracket, 2 minus P. I think this is where the students probably make a mistake, because you must remember that you must put that bracket there so that you know that you're supposed to multiply this negative in. Okay, guys, please don't make that mistake. Okay, and then you're going to be left with, okay, 3 to the power of 1 minus P minus 2, because you're multiplying this negative inside, you're multiplying it in, minus 2 plus P. And then what do we see here? We can just see that if you have to basically add the like terms of our exponents, we've got a minus P, a plus P, so those cancel, right? Because it's minus P plus P is equal to 0, 0P. And then you're left with 1 minus 2. And then what is 1 minus 2? 1 minus 2 is equal to negative 1. Okay, so therefore, that can also be written, 3 to the power of negative 1 can also be written as 1 over 3. Okay, we found that our common ratio is equal to 1 over 3. Okay, what does this tell us, guys? The fact that we found a common ratio of 1 over 3, what does this tell us? It tells us that we've got a convergent geometric series, right? Okay, because the value of our R is between negative 1 and 1, right? So how do we work with this information that we've calculated to determine the value of P? How do you work with the information that's given? Okay, another thing that we know, guys, we know that the formula for the sum of a convergent infinite series is given by, okay, the formula for the sum of a convergent. Since we've confirmed that this is in fact a convergent geometric series, then from there we can use the formula, the sum of a convergent infinite series, which is given to you guys as the sum of an infinite series, which is equal to a over 1 minus r. Okay, what does the a stand for, guys? The a stands for our first term, and then we already know that the r is the common ratio. Okay, so what was our first term of this geometric series? Our first term was, I'm just going to use orange. This was our first term, right? 4 times 3 to the power of 2 minus p. Okay, let's do that. Let's write it down. Found that our first term was 4 times 3 to the power of 2 minus p. Okay, and then what else do we know? We know that our common ratio was equal to 1 over 3, so we just substitute that into our equation. And then we also know that the sum of this convergent geometric series or infinite series is equal to, they gave us that it's equal to 2 over 9. Remember, guys, they gave us that it's equal to 2 over 9. So we punch that in into our formula. And then now we are simply going to solve. As you can see, guys, we literally just have one unknown, which is p. So if you can solve this equation, then you find your p, then you're done. Okay, then you are dealing. Right. So let's try and solve for our p. So what do? We've got 2 over 9, which is equal to 4 times 3 to the power of 2 minus p all over 1 minus 3. We can first simplify that expression there, which is going to be 2 over 9, which is equal to 4 times 3 to the power of 2 minus p all over, what's 1 minus 1 over 3? 1 minus 1 over 3 is equal to 2 over 3. 2 over 3. And then what can we do with this 2 over 3, guys? We can just simply multiply it on the other side. So it can be this. So we can just, to get rid of this 2 over 3, we can just multiply the left hand side by 2 over 3. So you're going to be left with 2 over 9, right? Multiplied by 2 over 3, right? And then what else we'll be left with? I'm just going to write this out so you guys can see what I'm doing. 2 minus p, right? And then you can divide by this 4. Okay, so we're going to divide by 4 on both sides. So you're going to have 2 over 9 times it by 2 over 3. And then you're going to divide by the 4. And that is going to be equal to 3 to the power of 2 minus p. All right. Do you guys see what's happening? Let's simplify the left-hand side, right? Let's simplify the left-hand side, right? By just punching everything into our calculator. 2 over 9 times it by your 2 over 3 all over 4. That should give you a 1 over 27, right? And that is equal to 3. We're going to basically now write this out. 3 to the power of 2 minus p can be written as 3 to the power of 2 times 3 to the power of minus p, right? And that tells us that we can divide by this 3 to the power of 2 on the left hand side. And what happens when you take your 1 over 27 and you divide it with your 3 to the power of 2? You get a 1 over 243. Simply punch into your calculator, guys. Let's not stress our lives. Okay, and then you're going to be left with 3 to the power of negative p. All right, and then what can happen now? What can we do now? Okay, that 3 to the power of negative p can be written as I'm writing all these steps down for you guys so you guys see what's happening. Can be written as 1 over 3 to the power of p. Do you guys agree? And once this is written in that sense, you can multiply the 3 to the power of p. You can multiply, I'm just showing you what I'm going to do. You can multiply the right hand side with 3 to the power of p so that it cancels. And what you do on the right hand side, you do on the left hand side, right? And then you'll be left with 3 to the power of p all over 243, which is equal to 1. And then you can just simply multiply the 243, your left hand side with 243 and your right hand side 243, and you'll be left with obviously 3 to the power of p, which is equal to 243. Let me show you guys what I mean. Okay, so you're going to be left with 3 to the power of p all over 243 with 1, right? What can we do now? Multiply the left hand side with 243, and obviously what you do on the left, you do on your right. You're going to be left with 3 to the power of p, which is equal to 243. Okay, or you can just simply here, for most learners, I'm sure you guys could have just seen that you could just swap the left hand side and the right hand side. So you can just say, because you're swapping your left hand side, which is your 1 over 243, and make it a 243 over 1. And what you do on your left hand side, you do on the right hand side, and it's just going to take you to 243, which is equal to 3 to the power of p. But if you didn't see that, then obviously these other additional steps are for you guys. Okay. Right. So now we can see that we're getting somewhere. We can calculate the value of p. This is where your exponential laws come in, guys. That's why it's very important that you guys study. Because if you don't study, actually the whole question, the whole paper is going to be hard for you guys to do, because they're trying to test if you can apply everything that you've learned and you can put it together. So make sure that you guys study, okay? All right, so 3 to the power of p, which is equal to 243. How can we do this matrix? How can we solve this equation, right? We can solve this equation by writing that 243 in terms of 3, which we basically, how to solve this in terms of your exponential laws. We want to have the same basis, right? And how can we have the same basis? We can have the same basis if we have this 343 in terms of a 3 base. You have a base 3 to the exponent of something, right? So how can you write 243 in terms of 3 to the power of something? Okay, you can just simply punch 3 to the power of 2 and check what you get. You get 3 to the power of 9. Okay, no. Then 3 to the power of 5. Okay, 3 to the power of 5. Yay. So that means that you take your 3 to the power of 9 is equal to 3 to the power of 5. And 3 to the power of 5 is the same as saying 243, guys. Okay. Okay. And therefore, why am I saying this is 9, you guys? This is p. Why am I saying 9? Okay. Which is 3 to the power of 5, right? And once we've got the same basis, we can simply drop the exponents, and you're going to have your p, which is equal to your 5. And then we're done. Okay, guys. Okay. So I'm just going to do a quick recap of your question 3.2. With your question 3.2, we know that the sum of this geometric series is equal to 2 over 9, and we basically need to determine the value of p, right? The first thing you need to do, excuse me, when obviously solving this problem is first get what the terms of this series are, right? So we find that obviously your T1 is equal to this series starts at p. So our first term, when you have to substitute that into the equation that was given, you substitute p when you see k, because that is how we start off this series, right? And then when you substitute that, we got our term 1 to be equal to 4 times 3 to the power of 2 minus p. We went on to find that now with our term 2, we need to substitute p plus 1 into our k. our k position, right? With term 3, we need to substitute p plus 2 in our k position. And with our term 4, we need to substitute p plus 3 in our k position, because we're adding on like that, right? And then we found our terms. From there, we found the common ratio, right? And the common ratio, we know that we take your term 2 over term 1, or your term 3 over your term 2. And we found that our common ratio is equal to 1 over 3. And what does that 1 over 3 tell us? It tells us, because we've got a common ratio that is between -1 to 1, it tells us that we are working with a convergent geometric series. And what do we know about a convergent geometric series? We know that the formula for the sum of a convergent infinite series is given by the formula of your S infinity, which is equal to A over 1 minus R. And from there, we know that our S infinity was the sum of our infinite series was equal to 2 over 9. And we also know we knew what our first term was, which is our T1. We substituted, and we also knew what our common ratio was, and we also substituted that in. And then here it was simply just mathematics. We're just simply solving. And then we found that we got 3 to the power of p, which is equal to 243. Then we asked ourselves, how can we write this 243 in terms of 3 to the power of something? Because we're trying to have the same basis so that we can drop the exponents. And we found that 243 can also be written as 3 to the power of 5. And therefore, we found that our p was equal to 5. Okay, guys, this is an amazing question that actually tested your knowledge of your exponents. It tested also if you guys studied your notes on what an infinite geometric series is. It tested your knowledge on sigma notation, right? So it put everything together. So you guys really need to make sure that you guys study. Please study. Okay, and that is it, guys. That is it for your question 3 of your November 2020 paper 1 mathematics exam. Please make sure that you guys are subscribed to the channel. Please comment, guys. Please comment. I will not stress this enough. Tell me, did I make the question easier for you guys to understand? Did I simplify it for you guys? What didn't you understand? Where did you guys lose me? Please, guys, comment. Your interaction will really be appreciated, because that will also help me better my explanations to you guys. Okay. Please share the channel with your friends. Please make sure that you hit the notification bell, because like I said, we are still going through your November 2020 paper 1 exam. Okay, guys, good luck with exams that you guys are currently writing. If I'm not mistaken, I think you guys were writing your economics prelim today. So yeah, guys, study hard, study smart, and subscribe to the channel. It will help you guys very much. And I'll see you guys on my next upload. We are doing functions. Okay, we are doing functions. If you haven't bought our data, please make sure that you ask your parents to get you guys data, because the functions one it's a lot. Okay, so make sure that you guys are loaded with your data, because I will be explaining everything on your question 4 in depth. Okay, guys, thank you so much, and I'll see you guys on my next upload. Goodbye.